So hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing strings topic and we were following sliding window pattern. In this we will do the next question, which is minimum window substring. So let's read the problem statement. Don't see this hard level because trust me, when I'll teach you, you will feel that the question is easy medium, not exactly hard. Problem says we will be given two strings S and T of length m and n. Okay, we have to return the minimum window substring of S. So basically we have to return the substring, that too of minimum length, such that every character in T, including duplicates also, is included in that window. Means here ABC is present, correct? So you have to find कि all the characters present in T should be present in that substring which you are going to give, and out of all you have to give the minimum string. So if you see here A, D, O, B, E, C, here A also includes, B also includes and C also includes, but the length is 6. But if you see this B, A, N, C, here also A, B, C includes and the length is 4. So you have to give this minimum substring. Question is very easy. Let's see the constraint. Constraint says m and n, which is the length of S and T, can go till 10 power 5. Okay, n is 10 power 5 means n square can become 10 power 10, and you know beyond 10 power 8 our code might give us TLE. Means beyond that it's not safe, hence we have to optimize. And when it is 10 power 10, for sure this code, like brute force code, will give us TLE. So let's first understand what exactly we have to do. We have been given T and S, and we have been said कि we have to find A, B, C. Means occurrence needs to be same. Means apart from this A, B, C, in your substring other characters are allowed, but at least these many substrings which are present in T with that exact minimum frequency should be there in S. What I said, we want the substring. So can I say A? Yes, A is a substring, but does this substring A contains everything of ABC? No, it only contains A. Okay, means we have to include this substring length. Now we have AD. Can we say AD contains ABC? No. But how we are checking? Can I say with the help of frequency count? Yes. So means first let's make the map to actually store the frequency for A, B and C. Okay, and this map is actually representing the characters and frequency for T. Now here we'll match, like here also we can make the map. How? A has frequency 1, D has frequency 1. Now we'll say ki, does this map matches with the T map? No, it does not. So hence this string is not valid. Okay, now we'll add O. Does this matches? No. Now we'll add E. Does this matches? No. Now, sorry, B. Does this matches? No. Still C left. Okay. One more character, E. No, still not. Now C, yes. I can say ki yes, now my map matches with this T map. Okay. So I can say ki this string till here is valid substring. Yes. So what is the length? 6. Okay, so we will save this much string length in our answer variable. So let's say in answer we have A, D, O, B, E, C. Okay, so do you think when we already found the substring from I is equal to 0, if you remember in my previous code we already discussed कि we actually create the substring from I is equal to 0 and we go till like wherever our condition satisfied. Then we move our I to next pointer, and again we start from I and we move ahead to find the next valid substring. Similarly we move I ahead and so on, correct? So here when we started from I is equal to 0 and J went till this C, and till here we found that this A, D, O, B, E, C is that substring which we need and which actually contains all characters of T. Means can I say this is valid substring? Yes. But don't you think if we'll move forward, means we'll add more character, even though it will be valid, but that will be of larger length. So hence can I say once I found that valid substring, we need not to move forward? Yes. Means when our I was 0, we found this substring as valid. Now moving forward does not make sense. So hence now next time we'll move our I at first index. And now again we'll initialize our J from first index and we'll see all these maps So how we'll see, again we will initialize our map. Okay, now this is for I is equal to 1. So first we will encounter D. We will say कि D has frequency 1. Does this map matches with my T map? No, it does not. Again O with frequency 1. Again B with frequency 1. Again E with frequency 1. Again C with frequency 1. Okay, till now B found, C found, but A does not found, so we'll keep on moving. Okay, so we'll add O with frequency 1. D with frequency 1 means we'll increment this. Now after that O also with frequency 1, so though basically we'll increment instead of adding now. Now we'll find E also present, so we'll increment the frequency. Okay, now again B, increment the frequency. Now A, so we'll add this. Okay, so from D to A, this is my substring, and if you see in the map, we have B, we have C, we have A, yes. Okay, now if you are thinking the frequency is greater than expected, it works because our task was to find at least the occurrences of these many characters with the minimum frequency whatever is required. So T said I want A, B, C one time. S is saying I'll give you B 2 times and C 1 time, A 1 time. T says yes, it works because anyhow your substring actually contains my ABC. So hence this substring is also valid, but the length is not valid because length we already found 6 and that was smaller to what we have found now because this is very large, correct? So hence we will not update our answer. But do you think we should move forward? No, because anyhow if we'll move forward we'll get more longer length which we don't want because the question asks minimum window substring. So again we'll break our J loop. Okay, so now next time what we'll do? Next time we will again update our I at I is equal to 2 index. Okay, so now for I2 we will again initialize our map and we'll keep on adding the characters. So first we'll add O1, then B1, then E1, then C1, then again O 2 times, then D for 1, E for 2 times, B for 2 times and A for 1 time. Now here also we find from here to here I can say ki yes, we have found our substring that is valid, means that contains all characters with that exact frequency, but this length is longer, hence we don't want that. But how we can check with exact frequency? For that, whenever we are making this map, remember you can make a function where you will iterate on this map and you can check कि this character A is present in this map or not. Yes, it is present, then its value means the value in this S map should be greater than or equal to this because we want at least this one na. So this value should be greater than equal to this. Okay, and whenever this condition fails, means suppose we want B3 but here we found B2, so hence we have to return false, saying this map does not match because we wanted 3B and we found only 2Bs. So it is very simple, we just have to actually create the substring, and meanwhile creating the substring we have to fill this S map, and whenever we are filling the S map we will make a match function where we will send this S match and T map, and that will consider and take care of ki at least this much frequency is present in S map or not. If yes, then it will return true, means that substring is valid. But even that substring is valid, our task is to maintain a minimum length substring, and at the end we will return that. So let's see the code for this. First we will make a map called T map, and we will run for that T to store all the character with the frequency in T map as said. Now we will initialize the string answer which is with empty substring, and we'll run the for loop for S length, the bigger one. One by one we will put every character in that map. Okay, and then again we'll run the J loop because you saw for number of substring we have to run our J loop from every ith position till n. So J will initialize from I till last. One by one we will read the character with the help of J from S string, and we will add that character with the increased frequency in the window map, and window map is nothing but S map which we were talking. So in that S map means bigger map will put. Okay, once we put, we will call this isValid or match function here. IsValid function, in that will send both the maps, and this function what this will do, it will iterate in T map and try to check the frequency of S map. If this is less than T, means the required was 3 and it has 2. means return false. And if this function returns false, definitely we will not run the if case. And if this function returns true, means that substring is valid. And if the substring is valid, now we have to check the length is lesser or not to update our answer. So here from I to j, we will read that substring and we will update our answer with that substring if that substring length is lesser than the answer length. Or else at starting, definitely if our answer is empty, so whatever the length we got, if you check, previously answer was empty. First time we found answer of length 6. So that too we have to update now. Because if you will not write this line, definitely whatever substring length you will find, that will be definitely greater than 0. And current answer length is 0. So you will never find this condition true. So hence at first when your answer is empty, whatever you found valid substring, that you have to put. And that's it. When you will run this, definitely it will get run, but it won't get submitted. Why? Because the time complexity. See, first you are running the O of n size to store the t characters in the map. Yes. Then plus O of n, like this I loop is running for n times, and inside this nested j loop is also running for n times, which actually makes it O of n square. And inside this also you are actually calling this function, which is, this is basically running for t map, like unique character size. And here, as the question does not mention ki the character will be of what type, it can be smaller and bigger also. So this size will be 256. Why? Because a smaller character, if you know, 26, bigger character, if you know, again 26, and considering other symbols as well, together makes 256. So in the worst case also, if all characters are unique, then the size of the map will be 256, which is constant only. But definitely these two for loops will make it O of n square, and n is 10 power 5, so n square will become 10 power 10, and hence this code will give you TLE. As expected, as you can see, because of these two for loops, because first we are generating the substring and then we are checking it is valid or not. So hence we have to optimize it, and for optimization we will discuss two different methods. Although both will be same, that is sliding window, but in one code we will do the space optimization. Let's see how. So if you know, in string we have discussed two patterns, 2 pointers and sliding window. 2 pointers we use whenever we want to discuss, like whenever we want to compare exactly two characters at that 2 points, correct? And we can decide which pointer to move ahead or behind. But in this case we want substring, correct? And whenever we talk about substring, we always think about sliding window concept. So here also we will discuss the sliding window concept, because sliding window actually reduces our time complexity from O of n square to linear. So let's see what's that sliding window idea. If you see, previously we counted this much valid substring, okay? Next time we found this substring valid, okay? So we found till here we got this ABC, correct? So when we hit this j here, so definitely even though when we are moving our I ahead, from the smaller part to j also, either the string will be valid or it needs more character. Does this sentence make sense? Again, from D to A, I said it is valid, okay? Now when I moved I ahead, definitely I removed D, but D was not even expected. So can I say ki till here to here also it is valid? Correct? Without checking also we can say, because the character we removed, that was not required. So hence without checking also we can say that this length is valid. But previously we were still making the substring and then we were checking. If you remember, yes, that is the repetition. Again, next time we removed O, and from B to A, can I say from B to A? Without removal, like without checking, I can say that from B to A is a valid substring, yes or no? Why? Because the character which O we removed, that was not required. So without seeing we can say that this is valid, but still in the substring solution we are again running the for loop on that. So that is called repetition of task which we were doing, and in sliding window concept we reduces that and make it to O of n. But how? So idea is very simple. You have two options. Either you can take help of two maps and you can take help from one map. Remember, you can submit in both of these. Time complexity will remain same. The only space complexity matters, because here you are using two maps, so definitely you will use twice a space, and here you are using single map. But the logic will be simpler in this, but little bit tricky in this, but not so hard. trust me. So first we'll see this 2 map solution and then we'll see this 1 map solution. You can skip if you want, but I will recommend to watch till the end if you are watching till now, because trust me, you will love both the solutions. So let's go with 2 map solution first. Okay, so 2 map solution says we'll make first T map, and here we'll save the frequency of A, B and C. Okay, now the new map, which is S map, that will take care of the characters from here, okay, one by one. As you know, in sliding window there are 2 phases, expansion and shrinking. In expansion and shrinking, we always start our left and right pointer, where right pointer is always responsible for expansion, correct, and left pointer is always responsible for shrinking. Okay, what is this expansion and shrinking? In expansion, right will keep on moving forward, and whatever it encounters, whatever character, it will add in the map. Okay, left pointer, whatever right pointer has done now, left pointer will undo that. Means if right pointer has increased the frequency and added the character, so left pointer will decrease the frequency and remove the character. So it's very simple. First, right pointer will do A add. So in S map, what right pointer does, right pointer will add the frequency of this A1. Okay, but how can we keep a track key this matches or not? For that also again we have to call that match function. But can we get rid of this? Yes, we can. Without matching also, I can tell you ki yes, this substring is valid or not. How much character we want? If you see from the length, can I say 3? Yes. Okay, so we'll maintain a count also. We want count 3. Okay, what character we encountered? A. So we'll check ki, is this A present in this T map? I will say yes, it is present. Means this is required 1. Yes. So if this is required 1, definitely decrease the count. Okay, so you will decrease the count saying, hey, 1 I got. Okay, so you will add this. Again, you will move this forward at D. Now you will add the frequency for D. And you will find ki, is this D present here? No, it is not. So hence count will remain same, saying we found D, but this is not required. Okay, again next time we'll move this R ahead at O. Again this we will add this O frequency here, and we will not touch our count because this O is not required by the temp. Okay, again next time we'll move this B forward, we will add this here, and we'll see, is this B present in the T map? Yes, it is. So we'll reduce the count again, saying ki we have got one more such character which we needed. Okay, what are those characters? A, B. Okay, now again we'll move R ahead. We will add this E, saying we have found E, but does this E required? No, it does not. So hence we will not touch our count. Again next time we'll move this C ahead, and here we found ki yes, C was required. So we will reduce the count to 0, and here we will add the frequency of C also 1. Okay, how to get this is valid or not? Of course, because count has become 0, means at R is equal to this pointer, and from left to R, whatever the string is, I don't know what is the length, but for sure if the count is 0, means from left pointer to right pointer, I have got all my characters, whichever was required. So with the help of left and right pointer, you can definitely count the length. Correct. So I can say the length is, like my answer is from left, like right minus left plus 1 is equal to 6 here. Okay. But as we have to give the minimum window substring, okay, of course this length is valid. Okay, do you think we should move our right pointer ahead? No, because if we'll move our right pointer ahead, we will get longer length, but we want shorter length. Yes, so what we have to do? Definitely we should shrink here. So when we will shrink, whatever task was done by right pointer, left pointer will undo that. Remember? So what right pointer does? Right pointer put the value, like character with the frequency in the map, and what it does, it reduces the count whenever that character was present in the temp. Now what left will do? Left will reduce the frequency here, and it will increment the count whenever that character is present in the map. Very simple. Okay? Yes. So why we are shrinking? Again saying, because till now we have got the valid answer, but now we want minimum window. Question asked for minimum, so we will reduce it. Okay? Okay. So what we will do, before moving this left pointer, we will read the character. We will find ki hey, we have to reduce the frequency of A in S map. So we will reduce the frequency to 0. Yes, and of course we'll see is that A present in tmap also? Because if it is, for sure R would have decremented the count for that. Now my task is to undo that. So now left will increment the count for that, and then only it will move ahead to D. Okay, now it has reduced. Now again from here to here, what you will check if the string is valid. For that, counts needs to be 0, but now it is not. So hence this substring is not valid, and when the substring is not valid, R keeps on moving. Okay, now next time R will move ahead at O. Okay, now this will add the frequency basically, and also it will check is the O required. No, it is not. So hence again R will move until count again becomes 0. Now it will go on D and it will add the frequency. Again D was not required, so it will not touch count. Now E incremented, but E was not required. Again it will move to B. Yes, it will move to B. B got added. Now this B is present, yes, but do you think we should decrement the count? Do you think so? Because as of now, as B found, you will decrement, it will say yes, count is 0 and the substring is valid. But do you think from here to here the substring is even valid? Because here A is not there, correct? Yes. But how you decremented the count to 0 now? So here only this, like only the presence of this character is not enough. The frequency also matters. And that's what is very important, because earlier if I would have shared, then you would have confused. So earlier what we did, if it is present, we will increase, and whenever L will shrink, it will decrease. But there is one more condition to increase or decrease the count, and the condition is the required frequency was 1. In the map, we already has 1, means the character which we encountered is not even required. So hence we will not touch the count, remember. So basically, again repeating, to decrement the count, it is very important that the character should be present, yes, and even if it is present, the frequency, like this frequency is 1, here the frequency is 2, okay. So this frequency needs to be greater than this one or equal to this one for sure, okay. But in this case it is smaller, means B is not required, okay. So hence in this case we will not touch the count and we will again move forward at A. Now as said, we will move at A, and here the frequency is 0, so we will increase to 1. Now we will say, is this A present? Yes. Is the frequency of A is greater than or equal to than this? Yes, it is equal. So hence this A is required 1, and now we will reduce the frequency to 0. Again, as the frequency is 0, so from this to this is valid, but even though it is valid, when we will compare with the previous solution which was from A to this C, this length is smaller, so hence this length is not valid. Again, even though it is not valid, means the length is maximum, we wanted minimum. Okay, from L to R it is minimum, but the question is, do you think we should move right pointer ahead or left pointer ahead? Definitely we want minimum. If we will move right pointer, the length will become maximum, so hence we will shrink. To shrink, what left does? Left will read the character. If this is not present, okay, it will not touch count, but it will decrease the frequency here, okay. So we will move by decrementing the frequency to 1. Similarly, we will move by decrementing the frequency of O to 1. Now we will move, correct, by decrementing the frequency to 1, but we found that B is also there in the map. But can we touch our count? No, we cannot. Why? Because the required frequency was 1 and before decrementing it was 2 now. This is 2, hence the required is lesser, we will not touch. Still the count is 0, still all like from O to this is also valid, from B to this is also valid, from E to this is also valid. But why we are doing? Because we are shrinking, keep on shrinking, because we want the minimum length, correct. So again for E also we will reduce the frequency, yes, and E was not even required, so we will not touch our count. Now for C, what we will do? We will reduce the frequency, so we will reduce it to 0. Again, this frequency, like this C was required, and before reducing the frequency was exactly matching, okay. So hence we have to increase our count, so we will increase the count. Once we increase the count by moving left pointer ahead, now we can say that from this to this is not valid, and as you can see, count is 1, not valid, and C is also not present, hence not valid. So when not valid, what will happen? Definitely our pointer will move ahead, so R will move at N. N will get added, but as N was not required, so it does not affect the count. Now C encountered, again the frequency of C will become 1, and as the required, like C is present, yes, and the frequency 1 1 matching. So hence we will, what will do, we will decrement the count. Again decrement the count to 0. Now as the count is 0, hence this substring is valid, but the length is greater. So now for minimum substring we will shrink, but before shrinking we will reduce the frequency of O, we will reduce, but as O was not required, so we will not touch count. Now D, reduce the frequency, but D was not required, so we will not touch count. Now E, reduce the frequency, but as E was not required, so now we'll move to B. Okay, till now also, like till D to this C, E to C, yes, all was valid, but once we found this B and C, like again saying this is also valid, length was 6. This is also, like from E to C is also valid, length is 5. Definitely our answer will get updated to E, B, A and C, but again when we moved here, B, A and C is also valid, and this is the shorter length till now. So we will update our answer to B, A and C. Okay, now we will try moving this left pointer ahead. We will move, but we saw ki B is there, required, and the frequency is also matching, so hence we will touch this count. So we will reduce the frequency of B to 0, we will increment the count. Now because the count is positive, means the length, the substring is not valid, and whenever the substring is not valid, we move our R pointer ahead, and in this case now when we move our R pointer ahead, we will come out of the for loop. Okay, so hence in just O of n we did this, but by using these two maps. So what is the time complexity? If you will see, R started from 0 index and it touched till last index, yes. Did we ever found R coming back again and restarting? No. So O of n for R. Again for L started from 0 and it kept on moving. Does this ever happen ki L also came back and it restarted itself? No. So when it does not restarted, means both are linear, means both pointers have touched every index at once. So in worst case also O of n plus O of n means O of 2n, which is somehow nearly linear only, which we call O of n, and the space complexity we use twice. Okay, so let's see the code, because we already have discussed the optimize approach and we don't have enough time, so we will discuss the code here direct. First we will make the T map to store the character and its frequency, whose T string. Okay, now we will initialize the S map, hash map, and we will initialize the left pointer, the count we will initialize with T length. You remember 3 was required for ABC, yes, and minimum length variable, basically this will keep a track of the previous previous encountered substring is minimum or the current one is minimum. So because we have to keep a track with minimum, so we will initialize this with infinite and we will initialize our answer variable. Now let's write the logic. First we will run the for loop for right pointer. One by one we will read the character with the help of right pointer. Remember, whenever we encountered the right character, we added in the map, incremented its frequency, and if that character was a part of T map, we decremented the count. Remember, that's what we will do. We will add this in S map, and if the T map contains that character, we will decrement the count, but along with that we have to check ki T map, like the frequency for that character required by T map, should be greater than equal to the upcoming one. Means suppose we want only one character and in S map we are encountering the same character but twice, means second time. So do you think we should decrement the count? No, because that is not the required character. So hence the frequency of T map should be greater, then only we will decrement the count. Okay, so now whenever our count will become 0, can I say that substring is valid? Yes. So even the substring is valid, we will only update when this current length is less than the minimum, like previous length. So this current length will be right minus left plus 1. If this is less than minimum length, then we will update the minimum length by right minus left plus 1, correct? And in the answer also, from left to right, we will add the substring of S. Now, added or not, but to get the minimum one, what we do? We shrink, and for shrinking we will read the character with the help of left variable, and whatever action has been performed by right pointer, left pointer will undo that, means decrementing the frequency of that character in the map and incrementing the count, but only if that character encountered by left is present in the T map, and also the character in the T map, if this is greater than S map, then we will do the count plus plus, because in that case R did the count minus minus. So L is basically undoing everything, and we'll keep on doing this until our count is 0, because all substrings are valid and we are actually trying to fetch the minimum length substring, and at the end we will return our answer. So time complexity is definitely O of n to fill this T map, and O of n for this for loop where we are running this right pointer. But now don't think because we are running this while loop inside, so this is nested, so this is n square. No, it is not, because here also we are actually taking r from 0 to n for only one time, and here in the while loop also we are moving the left pointer ahead but at last until it touches n. So in total O of n plus O of n, which is O of 2n, hence it is linear only. So now we can run the solution. As you can see, all test cases pass. So now we'll try to submit this. So this was your Java solution, and here is your Python solution. The approach is very same. We are using the 2 map here as well, and here is your C++ solution. Here also we are using the 2 map. But as you can see, the complexity is still low, even though it is linear. Why? Because we can still make it more optimized by using only 2 map instead of 1 map. And for that also idea is very simple. You remember here what we did? We first initialize our count variable with 3. Yes, correct? We initialized this with 3 and we decremented with the help of right pointer, and we incremented with the help of left pointer. Yes, because we were using 2 map. Now forget about S map. Now think, can we do by using simple 1 map? Can you do? Yes. We will initialize a left and right pointer here. Okay, we have this 3 and we have this. Okay, but now we have only 1 map. We already has this 1. Do you think with the help of right pointer we should increment this or we should decrement this? Definitely we should decrement. Means encountered by r, we will decrement this to 0 and we will reduce our count to 1. Why? Because this one was required. Okay, now we'll move ahead until the count becomes 0. Okay, sorry, my bad, this will be 2. Okay, now D. Does this D present here? No. So what we'll do, we will add the D with 0 frequency, but as we encounter D, so we have to decrement, so it will become -1. Why we are doing this? Because whenever all the frequency will be 0, we will consider that that is required. Why? Because we don't have 2 maps here to match the frequency. So even though it was positive, we are decrementing it to 0, and even if it is not present, so we will decrement it to -1, saying we don't want that. Whatever frequency are 0 now, that are the required and present in my current substring. Okay, so now again we'll move this r pointer ahead. O is not there. Again for O also -1. Now B, yes, B is there. We will reduce the frequency to 0, and now we'll reduce the count to 1 because this was the required one. Similarly, we will increment this E. Now E is not added, so -1 for this. Now we will encounter C. We will decrease the frequency of C and we will reduce the count to 0. Now as the count is 0, we can say that this substring is valid. So hence, we will add the answer here, A, D, O, B, E, C. Now as we want the minimum substring, so now we will shrink. So for shrinking, whatever has been done by R, that we will undo. Means this A, what R did, decremented the frequency, so this will increment the frequency back and increase the count back, and now we'll move this here at D. But as you can see, count is 1, so this substring is not valid so far. So now we have to increment the R pointer ahead. We will add this O. O is already there, so we will again decrement, because what R is doing now, R is decrementing the frequencies. So -2. Again we will move R at D. Again decrement the frequency, -2. Again we'll move this R ahead. Again decrement the frequency of E, -2. Again increment like this B, at B. B we will reduce to -1, because as you can see it is negative, means we wanted 1 and we are at -1, means we have got 2 such B's in this, and you can see this B and this B. Yes, still count is not 0, so hence we will again move this at A. Now as you can see, the A is present here, yes, and R will reduce the frequency to 0 back and reduce the count. And now as the count is 0, so from here to here, this one is valid one. So basically we are doing the same, but earlier we were using 2 maps and decrementing the count and incrementing the frequency in the S map. But as here S map is not present, so here we will just decrement and L will always undo the operations whatever has been done by our pointer. Logic is fully same, but we are using only one map here. So here is the code. We will use this single map. We will iterate, store all the characters here. We will initialize minimum length, left, count, everything. We will run the for loop for our pointer from 0. We will read the character with the help of R. Now in the map, if the map contains that character, so we will check if the frequency is greater than 0. If you saw here, basically you reduce the frequency for everything, but whatever, like whoever the frequency was greater than 0, for that only you decremented the count, right? So that's what we'll do here. If the frequency is greater, we will decrement the count, and anyhow we will decrement the frequency in the map for both the cases. Either the frequency is positive or not. And whenever my count is 0, I can say that substring is valid, and whenever it is valid, we will check the current length is lesser than minimum or not. If the current length is lesser than minimum, then we have to read that substring. So we will update the minimum length and we will update the substring from left to right in the answer variable. Now as that is valid, now we have to shrink, and what we do, we read the character with the help of left variable. In the map, we check if that left variable is present or not, left character is present or not. If the left character is present, definitely we will increment the frequency back to positive, because that has been decremented by right pointer and we are doing the undo operations. And if map character value is positive after incrementing, means that has been decremented by right pointer. So now we will increment the count, and we will keep on doing this like until the count is 0, means all substrings are valid, and we are finding the minimum, so we are shrinking. At the end we will return the answer. So here this code is also optimized one, because here we are not using two maps, so definitely we can submit this. So I hope you understood the brute force also, the optimized two maps also, and the optimized one map also. So this was your Java solution, and here is your Python solution. Similar logic, but we are using the single map. I hope you understood if you are from Python background also. And here is your C++ solution if you are from C++ background. Similar logic even if you are from C++ background. So I hope with this you understood, and we can go and mark the next question as done. Okay, so I hope you will also do that. And I know that this code was little bit hard and it was lengthy video as well, but all the approaches were very important. And if you are watching this video till the end, I hope you understood each and everything. And trust me, no one has actually taught all the solutions in single video, and that too how we can do using two maps, and why not directly one map, because directly one map is the most optimized one, like space optimization, and using two maps is not so. But why I did, because being a beginner or even intermediate, we all think of two maps. No one can think of one map solution at once on their own. So I hope you like the logic. So that's why I broke down from smaller to harder one, and I hope you understood each and everything. Sorry, not the harder one, because even the optimized one was also easy, I guess. So I hope you understood. If yes, do let me know in the comment section. Yes, understood. And please do like the video, because it gives me more motivation to make more such video for you all. And if you like the playlist and the pattern wise idea, do recommend the channel to your friends, and do subscribe if not yet subscribed. And that's it. All the sheet links, all my social media links will be there in the description. If you have any doubt, do reach out to me through social media. And that's it for this video. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family too.